Hey guys, in continuation with the previous session, today we are going to discuss about that beam deflections. So in that beam deflection, we are going to study in specific what is meant by double integration method and how can we do this, how this method which helps to analyze the beam deflection, and following that we are going to study about the moment area method. And these two different methods has been used for analyzing the beam deflection. It is not only for simply supported beam but also for cantilever beam we are using. Okay, and let me start with the double integration method. So we already know that double integration method is a procedure. We are going to finding the deflection level of the beam with the help of the double integration method. So it is one kind of method that we are using this equation moment m is equal to E represents it is the elasticity and I represents it is the moment of inertia, and d square into dx square that represents it is the equation of forces, or whenever the load has been applied because of the force it can make some moment. It can be represented with the help of d square y by dx square. So this is the deflection curve or the bent beam which can be used. That moment is equal to E into I into d square y by dx square. We using this is the basic equation for analyzing the beam deflection. Okay, so in order to obtain the y, the above equation needs to be integrated into twice. Okay, we have to integrate this equation two different times by using the integration. Okay, so here P represents, this rho symbol represents it is the radius of curvature, and Y represents it is the impact load, or because of the beam or because of the support the load has been acted over that. Okay, and this Y represents it is the deflection. Here the amount of deflection taken place in the beam and the support giving the load reaction which has been equated. Here m is equal to EI divided by rho. Rho represents it is the radius of curvature. When I am taking this curvature, for example, when I am take it as an inversion, okay, it will become an 1 by rho is equal to m divided by EI. This is equal to k. It represents the curvature. An expression from the curvature at any point along the curve which representing that deformed beam is readily available from differential calculus. The exact formula for the curvature which we are using is k is equal to this. We know that m is equal to EI into d square y by dx square, and we need to substitute this m value. Here the EI getting cancelled, and therefore we are getting this equation, this one. Okay, where dy and dx is small, therefore we need to neglect this equation. That curvature of the beam is equal to m is equal to E into I d square y by dx square. This is the basic integrated equation which we are using for analyzing the structure. So that integration once which can helps to yield the slope. That bending is what do you call that? That bending reflection is what do you call that? That is what do you call that? Slope. That slope can be represented by the equation is called dy by dx. At any point in the beam it can be taken. By integrating the twice, that deflection y for any value of x it can be represented. Okay, this bending moment m must be expressed as the function of the coordinate x before the integration, which means if we are trying to integrate this equation, because of the integration that object value and the range has been declined, or we can able to specify the point where it can exactly occurs the deflection because of the load. So that is why we need to analyze that bending moment m must be expressed as a function of the coordinate x before the integration. That is why we need to use the equation dy divided by dx. This differential equation is a second order equation that solution must contain two constants of integration. They must be evaluated at known deflection and the slope points with respect to the point of moment where it taken occurs as 0. Okay, so here we are doing the two different integration. The first one, for any kind of deflection we need to use this equation m is equal to ei d square y by dx square. With the help of this equation we are need to integrate this equation into two different times, and for this we need to assume there is a radius of curvature is there. This radius of curvature that we need to calculate by using this equation. Accordingly we can find out what is the curvature, and hence this deflection can be calculated with the two different type of integration. Let me see in detail in upcoming sessions.